this talk. It's great to be here to speak to you. Allow me to briefly introduce myself. My name is Jordan Moldow. I'm a staff software engineer on the database tools and automation team at Box. At Box, we're building the Content Cloud, a secure platform to manage the entire content journey for enterprises large and small. There's three main pillars to the Content Cloud. One is providing frictionless security. The second is powering seamless collaboration and customized workflow automations for company business processes. And the third one is giving you access to an extensive set of first and second party integrations and an API for building custom purpose software. My team, the database tools and automation team, is a key part of the foundation of all three of those pillars. We are one of a couple teams that works on relational database infrastructure at Box. We run hundreds of sharded MySQL instances comprising thousands of hosts spread between MySQL and our data access layer. Today, I'm here to talk to you about deploying Sharded Vitess Sandbox. At Box, we found ourselves wanting to explore newer technologies to see if any of them would be a good fit for use in the public cloud. Vitess was one of those technologies that we wanted to explore. And at first, it seemed daunting to set up a sandbox cluster. And it was a little bit to start out with. There was documentation on the Vitess side, but we were pretty new to the public cloud. And so there were a couple things we had to figure out for ourselves. My purpose here today is to show you, with the knowledge that I gained of how to set it up, how you too can set up a Vitess Sandbox cluster. And my hope is to significantly reduce the barrier to entry for anyone who's hoping to do a test drive of Vitess. And my goal here is, once I start the demo, to be able to have something that's working within 10 minutes, and then to be able to spend the rest of the time showing off some cool features of Vitess. There are some prerequisites to this, and we're going to go through most of these in this talk. The first one, having the Kubernetes CLI installed. We're not going to demo that. You're going to need a public cloud sandbox environment, which you will have to create yourself also. In this demo, we're going to be using Google Cloud, and the sandbox is already created for us. But then the next steps we are going to go through. So we're going to create a virtual private cloud network. Then we're going to create a Kubernetes cluster. We are going to configure the Kubernetes client to talk to that Kubernetes cluster. So we're going to go through all three of those steps live. And then there's this sub bullet of, if you're using GCP, you need to install the gcloud CLI on your computer. That part we're not going to go through live. So let's start the demo. Let's see if in 10 minutes we can do all this prerequisite setup and then actually run the Vitess Operator example and have a Kubernetes Vitess Sandbox in 10 minutes. Let's get started. The first prerequisite we have is to create a VPC network. This is pretty straightforward for the purposes of a simple sandbox. Most of the settings we're going to choose are just going to be the default ones. Give it a name. We're going to choose automatic subnets. And then the only other thing we needed to do was to make sure that we enable internal traffic so that all of the pieces within GCP can talk to each other. And that's it. We'll create that virtual private cloud network and then wait for that to be created. What we're going to do next, once this is done, is bring up a Kubernetes cluster within the Google Kubernetes engine. Once the Kubernetes cluster is up, we're going to use that cluster to bring up the control plane for Vitess, followed by the entire Vitess cluster. We're choosing Kubernetes because PlanetScale has an open source operator for Kubernetes that makes it super, super simple to bring up resources scale them up, tear them down, replace them. It basically takes care of all of the hard parts of running a cluster that you don't want to have to think about, and lets you focus on the hard parts of running a Vitess cluster that you do want to think about. So that's why we used Kubernetes, is just the speed at which we can get a working sandbox cluster up and running. Now that the VPC network is ready, we can go to the Kubernetes engine page and start creating our cluster. We're going to use a standard cluster type, and we're going to go through some of the tutorial steps to get some simple defaults for us, but we are going to customize it a little bit. I'm going to name it my first cluster. I'm going to use not the rapid channel, but the regular channel for the Kubernetes version. And the reason for that is because on the rapid channel, there's some additional configuration of service account permissions that you need to do. So regular channel it is. I'm going to use the default machine types. I personally am choosing to enable auto scaling, just so that I don't have to worry about provisioning VMs later on, but you can do what you want with that. And then I'm going to make a couple of additional changes here. Over in the node pool, I'm just going to start with 5 nodes, but you can experiment with that. And then we need to configure our network. So the network VPC that we created is available. We're going to create this as a private cluster since this is just for us. And we need to enable access to the control plane with these 2 checkboxes. I'm going to use that suggested IP address here for the control plane IP. And this just needs to be something that doesn't overlap with something that's already in your Google network. And the other thing that we need to enable here is that we want to enable control plane authorized networks. What that's going to let us do in a few minutes is allow us from our terminal on our own computer access this private network. And all the other defaults should be fine. So we're going to go ahead and create that. And this is going to take a couple minutes to run, hopefully less than 10. So while that's running in the background, I want to explain in a little more detail what we're about to do. So I promised that we're going to be able to set up a Vitess Sandbox really quickly. And the way that we're going to accomplish that is via what's called the Vitess Operator. And this is a piece of open source software provided by PlanetScale, which makes it very trivial to use Kubernetes to set up your Vitess cluster and keep it running. And it really allows you to skip the parts of setting up a cluster that are just a lot of boilerplate and manual steps, and lets us focus on the important aspects of what we want to do with our sandbox. If you're not familiar with the word operator with respect to Kubernetes, there's this quote from the Kubernetes website that explains it in high-level terms. So it's a software extension to Kubernetes that makes use of custom resources to manage applications and their components. And you use Kubernetes principles in the operation of this operator, notably the control loop. There's some words here that might not be familiar, so I'm going to go through them. When they say custom resources, what they mean here is a custom type that you build into the Kubernetes API. And when you do that, you also enable a new set of REST endpoints that go along with that type and integration with the command line client. With that API type, you create the schema that you want and validation for that schema. And this is on the people who developed the operator. So in this case, PlanetScale created these types already, such as Vitess cluster, Vitess key space, Vitess shard, etc. And what you do as a user of the operator is that you store the desired state of your cluster, your key space, your shard, etc. What the control loop in Kubernetes consists of two things. Kubernetes rather, will discover the current state of the cluster. It will also discover what the desired state is, which is stored in those API types. And then it's going to constantly push the state of the Kubernetes cluster towards that desired state. So, for example, if you said that you wanted 5 instances of Vitess and one of them dies, then it will bring the 5th one back up. It's kind of like a thermostat where you set a desired temperature, and when the temperature deviates, it pushes it back towards that temperature. And so in our example of Vitess, the operator is going to describe the state that you want of a Vitess cluster, and then the control loop is going to create that based on what you asked for. And then throughout the lifetime of the cluster, it's going to continuously keep the correct number of shards and other resources running. And then the last thing that's mentioned in this definition is about controlling resources. And in Kubernetes, there's a lot of different things to control. We have things like authorization, access controls, service accounts. If you're storing things, you're going to have persistent volumes. If you're running applications, we have deployments, replica sets, pods, etc. And then if you're serving traffic, you have services and endpoints. All these things that I mentioned are first-class built-in types in Kubernetes, and they're relatively low level compared to our Vitess cluster, Vitess key space, etc. Basically, we are going to create a high-level Vitess cluster definition, and the operator is going to translate that into these low-level services, deployments, pods, service accounts, etc. Here's some links of information about the Vitess operator specifically, and also some of the resources that we're going to be using in a moment to set up the example cluster. Once this cluster is ready for us, which hopefully should be soon, there's going to be very few steps that we have to follow to actually get our Vitess Sandbox up and running. And in a nutshell, it's just going to be these 4 commands. So we're going to take the Kubernetes command line, and we're going to apply this operator.yaml file, which is provided by the Vitess project. And that is going to bring up the operator component inside of Kubernetes. Next, we're going to do a similar command, but now we're going to do our custom cluster definition, which is going to have that high-level custom description of everything there is to know about the cluster that we want. So the number of shards, the names of the key spaces, the number of gateways that we want, etc. Once we run that, the cluster is going to come up, and it's going to be in a blank default state. And then what we're going to do is we're going to install the tables in our schema. So we're going to run this apply schema command followed by an apply V Schema command. Now that the Kubernetes cluster has been fully created, we're ready to drop into the terminal and start performing operations on it. I previously installed and authenticated with the gcloud command line tool for interacting with Google Cloud. I'm telling it that our cluster exists in the Central 1C zone, and I'm going to grab the credentials for the Kubernetes cluster and point my Kubernetes CLI at that cluster. I mentioned that we created a private network in the previous steps, so we need to tell Google Cloud that we want to give our IP address special permissions to talk to the cluster. So these 3 commands are grabbing the currently authorized IP addresses, getting our current IP address, concatenating those lists together, and then posting it back to GCP to give the full list of authorized IP addresses. And now that this is done, we have permissions to talk to the cluster. We can run a sample Kubernetes command to see what is running there. And so to start out with, we have a bunch of utilities that come up automatically with the Kubernetes cluster. We can also see that in the UI as well. If we go to connect and go to the workloads dashboard, we can see all of these same pieces of information here as well. Now we're going to begin following the Vitess instructions for bringing up the operator, followed by the Vitess cluster itself. I previously cloned the Vitess project, and I'm in the operator directory, and I can go ahead and run the instruction for installing the operator along with all of its custom resource definitions. And that's it. The operator is now installed, and I can run the Kubernetes command to see that the pod is already up and running. You can also see this in the GKE dashboard as well. I'm going to filter out all of the system objects so we can more easily see what's there for Vitess. And after refreshing, we can see the Vitess operator deployment. Next, we want to bring up our cluster, and we have this file with the initial cluster definition, and we're going to apply it onto the Kubernetes cluster. You can see what it did here was it created a Vitess cluster called example and also installed the shared secret. And that was all that file did at the highest level. Let's look at the pods again. We're now creating an etcd cluster of 3 separate nodes. We're creating VT tablets, which I'll explain momentarily. We're creating a dashboard and a gateway, and that's the operator that we already had running. And once these are all up, then we will have our Vitess cluster. Let me just briefly, at a high level, tell you what these things are, and I'll go into more detail once the cluster is up. There's this etcd cluster here that serves as Vitess's topology service. It's going to store in this etcd cluster information about all the different parts of the underlying Vitess cluster, the shards and all of the replicas within each shard, and that's going to end up being used by the gateway when it's doing queries. And we also store pieces of the sharding schema there as well. The tablet is, or the tablets rather, are the pieces that actually run MySQL. Inside of the tablet, there's going to be MySQL itself with all the data that is stored in MySQL, but then there's also going to be a Vitess wrapper around that. And then we have the gateway, which is what actually receives the queries from your application and routes them appropriately. Let's see if this is ready yet. Okay, everything's running. So we now have our Vitess cluster up and running. Let's continue on with the rest of the cluster validation and setup. The next step is going to be running port forwarding. I'm going to do that in a separate terminal. What this is doing is it's forwarding a couple of ports on our local host over to different parts of the Vitess cluster. For example, port 15000 is going to be a Vitess dashboard. So we can open that up in our browser, and we can see that we are now connected to Vitess. We can see that in this example cluster, we set up a key space called commerce, and right now it has a single shard. We also have an alias that we can configure in our main terminal window so that we can now use the MySQL client to connect to Vitess as well. So we just hit MySQL and we're connected to Vitess. You can see we have some standard MySQL databases, but we also have this commerce database, which is the matching database for the key space that is created in this example. Right now, there's no tables. We haven't created any yet. So we're going to do that momentarily. The last thing that we want to set up is the alias for the Vitess client. I'm going to do this slightly differently because it's, in my opinion, a little bit better to use a Docker image to use the Vitess client. That way you can change the version whenever you want. So I'm going to make sure that I have the Vitess client Docker image available, and then I'm going to install this alias instead. What this alias is doing is it says every time I run the Vitess client, we're actually going to do a Docker run of that image we just pulled. We're going to use host networking. That way we can take advantage of this 15999 port that we're forwarding. And there's this special incantation here that helps route the Vitess client to that port that's being forwarded. We can see here that we now have access to all of the subcommands that come with that client. And we're going to specifically run the ones that are going to create our schema. So first, this is just applying the actual SQL tables. And then this is going to be our Vitess sharding schema. And in this example, we have 3 tables that are now registered in Vitess, and they are currently unsharded. We connect to MySQL again. We'll be able to see those tables that we just created. So we now have a working MySQL cluster. This example also provides us a script to insert some sample data, which we will run momentarily. But now that we have the cluster set up, I want to switch for a moment to talking a little bit more about what it was that we just accomplished. At this point, we've succeeded at deploying a Vitess Sandbox cluster. Unfortunately, it took longer than the 10 minutes that I was hoping for when I wrote my title. It took us more like 15 minutes to get the cluster up. And then after around 20 minutes, we had put in the schemas and finished exploring everything. Most of that time was us waiting for Kubernetes to come up and me talking during that. So if you already have a Kubernetes cluster, this time will end up being closer to 10 minutes. Now I want to talk a little bit about what exactly Vitess is, because I've kind of mostly glossed over that. We saw that when we connected to Vitess via the MySQL command line, we saw that it presents itself as if it was a single MySQL database, and it provides just a single connection to the Vitess backend. So what exactly is it besides this illusion of MySQL? Well, under the hood, it's a massively scalable, highly available database system, which is why me and my team were interested in investigating if it would be a good fit in our fleet. It was designed originally at YouTube, and it was designed to be a cloud native database, meaning that from day one, it was designed with the intention of being run in an ephemeral cloud environment where you might have VMs and containers dying a lot more frequently than a bare metal host that you control in your own data center. And the massively scalable part is that Vitess really lets you scale to as many shards as you want, or as many vertically partitioned databases as you want without really skipping a beat, all the while maintaining that MySQL compatibility and high availability. The test project has a mission statement, which is to be the most performant, scalable, and available NoSQL storage system in the cloud. I did briefly mention parts of the architecture when we were bringing up the cluster, but I'd like to refer to this picture now. Over on the left, you have your application. Your application is going to connect to the Vitess gateway, and there's going to be multiple instances of this VT-gate service running in multiple containers across multiple machines, and they're all stateless services. And so your application is going to connect to one of these gateways via a load balancer that you set up. And once it's in the gateway has all of the logic that's needed to parse your query and figure out what to do with it. So it might need to send it to one database, or if it's a query that is going to a sharded database, it's going to need to figure out which shard or shards to route the query to, and also might need to rewrite the queries a little bit. Those queries get routed to one or multiple of shards, and each shard is going to consist of a primary database and then replica databases, which are there to take over if the primary dies, or just if you have traffic that is read-only that you can send to the replica. Each database actually consists of two different processes. So there's the MySQL that we know and love. This can be whichever MySQL you want, MySQL 5.6, 5.7, 8, or Percona variant. But then on top of that runs this VT tablet process. And this is actually what's receiving the traffic from the VT gate and doing some further processing on that query before finally sending it to MySQL, receiving the data back, and then forwarding along again. The way that the VT gate and the VT tablet communicate, or rather the way they discover each other, is via this topology service, which was etcd in the Kubernetes environment that we set up. Each tablet is going to register itself with the topology service to let Vitess know where it is and what role it has. And then the VT gates subscribe to that topology service. This is another diagram showing the same thing with additional arrows showing the relationship between the tablet, the gateways, and the topology service. We also see that the dashboard also talks to the topology service, and the command line client also talks to and can modify the topology service. Here's some external references and resources that you can use if you want to learn more about Vitess. And then the main point that I illustrated earlier, but just want to call additional attention to, is that the Vitess operator really trivializes the setup of your Vitess cluster, and it allows you to focus on important aspects of your experiment. And I use the word experiment here, and I use the word sandbox in the title, because I think that's where you are first going to run into Vitess, is when you want to run experiments on it and set up a sandbox. And it really shines because it really cuts down the amount of time it takes to get a working sandbox. That being said, Vitess Operator can also be used in production as well. It's not just a service meant for sandboxes. And we saw that once you actually have a Kubernetes cluster up and running, it's approximately 4 commands to actually bring up your cluster and your schema. If we wanted to start completely from scratch and start everything over again, you can issue a single command to completely delete everything in the cluster, and you can edit that YAML file and then repeat bringing it up again. Or if you don't want to start from scratch, if you just want to do some sort of rolling update to your cluster, which is normally what we would be doing, is you can simply edit that YAML file and then run the kubectl apply command again, and that's going to update the cluster in place. And now we'll show exactly how that works in the environment. I'm going to bring down the Vitess cluster by issuing a Kubernetes delete operation on the YAML file, and that deletes the Vitess cluster and its shared secret from the Kubernetes cluster. In the Kubernetes dashboard, we can see that all the resources associated with the Vitess cluster are now terminating. When I bring it back up, I want to use a slightly different configuration. I want to bring up the new experimental Vitess orchestrator or VT-org component. Just a warning, this component is not yet GA'd for use in production, but it's really great to use in a sandbox environment because it'll watch all of our tablet resources and elect leaders if the previous leader becomes unavailable or dies. And this is a sneak peek of what these YAML files look like. It's just one big file that contains all the configurations for how we want the cluster to look at a high level. So here we have our commerce key space that we saw before, and we've added a Vitess orchestrator configuration to this key space. We're specifying the machine resources that it needs to run, and then we're telling it to watch every cluster that we bring up. So we're going to apply this file, and that is once again going to create the Vitess cluster from scratch. And that will take a little bit of time. So this is bringing up the Vitess orchestrator. Otherwise, everything else should be the same from before. And when it's up, we're going to run the port forwarding script again, but this time we're going to run it where it's also forwarding the port for the orchestrator UI as well, so that we'll be able to see that. Most everything is running now, so I'm just going to run this so that we can see the orchestrator dashboard. So that's going to come up on port 3000. And here it is. So we see that we're watching the one and only cluster right now, which is the commerce cluster. And then clicking into there, we see the 2 tablets that exist. And those match the 2 tablets that we can see in the Kubernetes dashboard, these 2 right here. And we can see that one of them is the leader and one of them is a replica. And from this dashboard, we can perform operations on the cluster that you would expect if you used the open source MySQL orchestrator before. For example, if I want to decide that this one should be the primary now, I can just drag and drop this and promote it. Yes, I do want to promote it. And there we go. We now have a new primary and a new replica. And with this VT-orc experimental integration, orchestrator operates as a first-class citizen of the Vitess cluster. And as part of doing this leader election, not only has it changed the replication flows between the two tablets, but it has also updated the Vitess knowledge of the topology as well. So the two will stay in sync. Now that we've done that, I want to show an example of modifying the cluster in place. So I'm going to go here, and what I would like to do is increase the number of gateways. So right now we only have a single gateway, which we can see in the dashboard. We have a deployment of just one. So I'm going to increase that. Let's say that we want 4 gateways, and let's increase the CPU request to 200 millicores. So I can do that and then do another apply command. So we're not going to delete it this time. We're just going to apply it. And this will do a modification in place rather than deleting it and bringing it back up. Refreshing the dashboard, we see that we have now a maximum of 4 pods available for the gateway, and Kubernetes will work on bringing up those 4 over time. Right now, it looks like we don't have enough nodes provisioned, but because of the auto expanding functionality that I implemented when we created the Kubernetes cluster, we should shortly have additional VMs that will allow those gateways to come up. In the meantime, I'm going to add some additional objects to our Kubernetes cluster to provide additional value. I'm going to add them first so that they'll come up, and then I'll explain what they are. This one is going to be an internal load balancer. This one is going to be a storage class, which will allow us to use solid state hard drives. And this one is going to be a service account secret for performing backups. While those are coming online, let me show you what's in those files. So the load balancer looks like this. We're creating a GCP internal load balancer that's going to load balance across all of the components labeled as VT gateways, and it's going to accept traffic on the 3306 port. Once this load balancer is online, anywhere inside of GCP, you can route to the gateways using the static IP address of this load balancer, or within Kubernetes itself, instead of hard coding the IP address, you could also use this name of the load balancer instead. The storage class here, I took most of this from the Kubernetes documents for Google Kubernetes Engine. Basically, we're allowing use of a persistent solid state drive for the hard drives that are mounted to all the VT tablet pods. So this by itself doesn't do anything. It just is making the solid state drive available within the zone that we're in, and we'll be able to reference that in a moment. And then the third thing is the secrets for the backup controller. I'm not going to show you the private key, but this is basically what the file looks like. There's instructions for how to do this on the internet. This is all of the information minus the private keys that we need to load into the Kubernetes cluster to be able to have the Vitess backup controller talk to a Google Cloud storage bucket and save and retrieve backups. Refreshing the dashboard, we see that the gateways that we brought up earlier are now online. And if we go over to the Services tab, we can see the load balancer that we just created and the IP address that you can use to reference it. Note that this is an internal load balancer, so it will only be usable within GCP. If you wanted to connect to a load balancer externally, I believe you would need to create an external load balancer, although that's not something I've experimented with. We set up the service account for backups, but we need to actually configure the Vitess cluster to actually take and read the backups. So we need to make another modification to this file with the configs. And we're going to add a new section here with everything about the backup controller. So we add a section here called backups. We're going to add a location here. This location I gave an arbitrary name. This is a bucket that I've already set up. I'll post instructions online for what I did to set up this bucket. And then the prefix is just an arbitrary prefix that's going to be used as a path within the bucket. This is the name and the file name of the secret that we just added a minute ago. I'm using the extra backup engine for the backups. And then the name of the service account that's used is Vitess Operator. So we're going to add that. And then there's one other thing we have to do. We have to go down to our key space definition and go down to these replication settings. And in the replication settings, we have to tell it that when we're starting a new shard up for the very first time, we want it to take an initial backup. Tablet needs to also be configured to point to the backup location that we wish. Earlier, we had defined the name of the backup location as this, so that's what we set. We also want to use the new storage volume type that we created with the access to the solid state disks. So we're also going to edit the definition for the tablet. That way, when a tablet comes online and it needs to create its local disk, it's going to use a solid state drive rather than the default kind. Since we're adding a new backup functionality to the startup process of the tablets, I'm going to go ahead and increase the CPU just so that hopefully the startup process goes a little quicker. And since things have changed a bit significantly, I'm going to start from scratch. So I'm going to bring down the whole cluster and bring it up again. Now that orchestrator is online, I'm going to rerun our port forwarding so that we can view the orchestrator dashboard again. It's not finding any clusters yet because the tablets still need to be brought online. Okay, supposedly the tablets are available now. Now that we have backups configured and we recreated a cluster from scratch, I'm going to set up the schema again. And then I'm going to insert data into those tables. Now, if we connect to MySQL and we connect to the Commerce DB, we see we have some data in here. With data in here now, I'm going to take another backup. And now I want to show what happens if the leader were to be killed. Going into the orchestrator dashboard, we can see that the leader is this one, IP address 1072.63. We can also see its alias, which is this. So we're going to go look for that in the workloads dashboard. And let's delete this tablet. Orchestrator should recognize in a few seconds that the tablet isn't available anymore. Yep, it recognizes that. And it elected a new leader. So we should be able to go back to MySQL and see that the data is still there. That makes sense, since this was a replica that was promoted to be a leader. Now let's see what happens if I were to also delete this one as well. So now that one is being terminated, but the replacement for the one I killed is back online. So we can see that it's now recognizing that the other one is dying. It's going to try and promote a new leader, and it has done that. So now this is a brand new pod. This one did not exist when we took the backup. Data is still there, so the backups are working. I would also like to show how rolling upgrades should now be working. I'm going to make a demo change to our cluster definition. What I'm going to do is I'm going to decrease the CPU back to 100. And I'm also going to define resource limits as well, set to the same 100 value. And I'm going to apply this back to the cluster. And what we'll see here is that the Vitess operator is smart enough to not take down all of your tablets at once. It's going to, in each shard, take down one at a time. That way you still have most of the cluster that's healthy at a time. So you can see here, one tablet is terminating, but one is still running. And if we look at orchestrator, you can see we have one still running. Refreshing the page, another tablet is coming up. And orchestrator has already connected it to the topology. And in a little bit, once this tablet is fully up and some time has elapsed, the orchestrator will continue iterating and it will go on to the next tablet and take it down. If the tablet happens to be the current leader, which it is right now, the Tess Operator is going to trigger a planned failover, and it'll swap them so that it's not the leader anymore. and then it will execute the takedown and then the replacement of that tablet. The last thing I'd like to walk through today is the sharding process in Vitess. With the demo that we started out with, we started with a single unsharded key space. I'd like to switch that to a sharded key space. So I'm going to go here and I'm actually going to duplicate our key space. So I'm going to copy this whole block, duplicate it, but I'm going to name the new key space customer to follow along with the Vitess tutorial. And in this partitionings, rather than one, I'm going to say that we're going to have 4 partitions or 4 shards. And I will apply that up to the cluster. And that should trigger the operator to start scheduling a bunch of new tablets and then trigger their initial backups on it. And that might take a little bit of time since we have to provision some new VMs to handle this new set of pods. We can see that some of them are already coming up. While we're waiting for those pods to come up, I'm going to talk through what we're about to do. We're going to execute a Vitess move tables operation, which is going to relocate some of the tables from the previous key space to the new key space. Since the old key space is unsharded and the new key space is sharded, one additional thing we're going to need to do besides specifying that move is to also specify how the tables should be sharded in the new key space. That uses a framework in Vitess known as Vindexes to mirror regular indexes in MySQL. We're basically going to define on the 2 tables a Vindex that says that it's sharded by the hash of the customer ID. And that's going to be true for both of the tables that we're moving. The pods are available now, so I'm going to go ahead and execute these commands to create the V schema. I skipped the last step here, which would, in the reshard workflow, be used to create the schema on the destination set of shards. But since I'm mostly following the move tables workflow instead, that's going to be taken care of for us. I'm going to start preparing to execute this move tables command, except I'm modifying this slightly since we want to move it directly to a sharded key space. I'm going to make some adjustments to this. And the move tables workflow should be starting now. So this is going to start moving the content from the source key space to the destination key space, and then set up a replication stream between them once it's done. Let's just look around a bit in Orchestrator. So we have our original uncharted cluster, and now we have a bunch of shards present as well. Let's take a look at this one. So we've got 2 replicas in this customer -40 shard. If we go to the home page here, we see there's a new key space here serving 4 shards called customer. We're going to see whether the workflow is done. It should be, since the tables were very small. And we can see that 5 rows were processed already, and that's all we had was 5 rows. So we're ready to start completing the operation. So the first thing to do is to switch the reads over to the new shard. And then the final step is to switch the writes over to the new shard. And as of this point, all the traffic should now be going to the new key space, the new 4 shards sharded key space. And if we're satisfied with that, we can conclude the operation by dropping the tables from the original key space. Let's see what we have there now. So let's look at the original commerce key space. And if we look, the 2 tables that were originally there are gone now. We just have the product table that we didn't move remaining. And then we have these 2 new sequence tables. These are part of how Vitess handles doing auto increment in a sharded key space. I'm not going to explain that. You can read more on the Vitess website. We're going to look at the customer key space. See that we have 2 tables in this key space now. And let's look at what data is in there. And we can see that we have all 5 of our original rows, despite the fact that we are in a sharded key space. The Vitess gateway is able to recognize that this is a sharded key space and recognize that this query has to fan out to all shards, and it will do that and gather the results and return it back. And we should see the same in the other table as well. But suppose I only want to get 1 value, and we know that this is sharded by customer ID. So if I do this, it only has to go to a single tablet and retrieve results from that single tablet. And so we can go back to the Vitess dashboard. Once again, we have these 4 shards serving, and we still have the commerce key space as well, but it's only serving a single table now, and it's still an unsharded key space. Unfortunately, that's all we have time to cover for today. We've only just scratched the surface of Vitess. There's a lot more cool stuff that we didn't get a chance to cover. If you're interested in learning more, these are resources that you can utilize in order to continue your journey through Vitess. You may also feel free to reach out to me at my email address at the bottom there. I'm also planning on posting code snippets and some additional explanations of what we did up on my GitHub, so you can go looking for that. I know it ended up taking more than 10 minutes, but we were able to demonstrate that in about 15 to 20 minutes, you could bring up a Vitess Sandbox completely from scratch using the public cloud and Kubernetes, which I think is really cool and very valuable if you're trying to do a quick proof of concept. I hope that what we covered in here can be useful to you. And if there's pieces that you think are missing, again, feel free to reach out over email and I'd be happy to chat. If you're interested in learning more about what we do at Box, we have a few other talks happening at Percona Live this year. There was a change data capture talk that happened earlier and should be online already. We have a talk about delivering large projects, and then we have a talk that I'm giving tomorrow about a data structure for recording sharding denormalizations. Thank you again for attending this talk. I really hope it was valuable. Enjoy the rest of your conference.